as Introduction to LaTeX. So in this workshop, we would like to learn how to typeset in mathematics. Usually we came up on kind of an assignment, homework, sometimes take-home quizzes that we need to type them in LaTeX. And most importantly for you is when you reach to Math 498 and Math 499, where you need to write a whole report in mathematics, then you will really need to use LaTeX because it will make the final report better and it will be even easier to type compare if you try to type in Microsoft Word. So, table of content for this session, we will talk a little bit about LaTeX, the idea behind LaTeX, and brief history about LaTeX. Next, we will talk about two important things in LaTeX. One of them, we call it editor. The other one is the text distribution. So you need to know the difference between those two. We will talk about installation and the structure of the document and preamble. And then we will talk about how you can write symbols, formula, mathematical formula, and the most important is the article class, as well as how you deal with environment in LaTeX. So we have so many things, we will go through them, we will survey them as we go along. This session will be divided into two parts. The first part, I'll go over the slides, and the second part, we will do hands-on. So I will show you how we write in LaTeX, how is the output is coming, and how we can improve our documents. So start with LaTeX. Usually LaTeX is pronounced as lay, L-A-Y, and then tech. Or if you can say the kha, you can say LaTeX. Sometimes LaTeX, and that's the way we do it. We never say LaTeX. The X at the end, we don't pronounce it. And what is LaTeX is a mathematics typesetting program. So it is used to type mathematics equation, mathematics report, and so on. And this is the standard way for professional mathematical writing. And it was created in 1978 by Donald Knuth from Stanford University, and it was called at the beginning TeX. Later, people trying to enhance the TeX, and they came LaTeX, which is more user-friendly, more easy for us to use the codes than the one we call it LaTeX. And the current version that we are using is LaTeX 2 Epsilon, which is LaTeX version 2, and then they add like 2.1, 2.2, 2 point something. Usually we use Epsilon, as we all learn in analysis, to use Epsilon to differentiate small numbers. So this is a brief history about LaTeX and why do we use LaTeX compared if we want to use Microsoft Word. As I said, LaTeX will make things much easier and the output will be much professional. So we will achieve a very high standard with minimal efforts. Now, in LaTeX, it's kind of, we will remind you of any programming language you have learned so far, like Java, C, C#, or even Python. It comes with two things. The first one is what we call it the editor, where you will write your code as a file. It will give you all the facilities to copy, paste, you type the actual code, and then we will have something we call it here text distribution. And distribution is the engine that will read your file and it will give you the output as a PDF with the mathematical notation required. So if you are familiar with programming language, this will serve like a compiler to you. So you will have editor, you write your source code, and then the distribution will give you the output. So the markup will be written in the editor, and the file will be saved as .tex, TEX. And then the distribution will read that file and will convert it into PDF. And previously, they used a different format called DPI or PS. And by the way, you can even have it as an image. You can do everything using this distribution, which is the engine. So this would be the second layer of typing in LaTeX. Now, for installation, we will go over the Windows. If you would like to install this in your PC, if you have a Windows, you can use or go to search on MacTeX distribution. That's you need to download that that program first. And then you can use any editor you like. Usually in Windows, people like to use something they call a Text Studio. Again, those are free, available online. Just download MikTeX, which is distribution, download the editor. They will join to each other and they will work seamlessly. Next, if you have Mac, you can use MacTeX, which is the standard one for MacBook. And you can use the editor from, which we call it Tech Shop. In this session, we will work mostly on the cloud. And for the cloud, we have a very nice website called Overleaf, which I highly recommend using Overleaf as a beginner because it will give you more facilities as well as it will help you share your file with other people on the cloud. So you can collaborate, you can correct your mistake, and Overleaf is much user-friendly than if you download it in your computer. So as a beginner, we will go over Overleaf, and that's what we will do our hands-on today. Now, this is the most important part you need to understand about LaTeX, which is not something you can see it in Microsoft Word or in any other editor. The document will be divided into two parts. You will have a part which we call it document, where you need to write your code. And then we have another part called preamble, which you will define the commands. You will define the tools that you will use in your document. So the preamble will not be your output. It will be just basic command, basic function you need to call, and the document will be turned into your output. It will look something like this in this picture. So at the beginning, you will have so many commands. You will tell your LaTeX about those commands here in the top part, in the preamble. And those commands are just basic commands he just needs to understand. And where your output will be, it will be in something we call it document parts. I'll show you in a bit how we do the document part, but you will need both in order for your distribution to be able to read your documents. So the preamble, you will tell the text editor what kind of document you are making, what package you are using. It will give title, author, and so on. And the document part will be the body. Whatever you write in the document part, this will turn out to be your output. And now it's a very good time we go and practice a bit. Now, before I go and practice what I need to practice and show you how we write the commands and how we build upon the LaTeX, it would be a good time if you have a question, you can unmute yourself, ask me any question of this little introduction while I just prepare the practice. Or you can even write in your chat if you have a question. Okay, if you don't have a question, let me go to Overleaf. You just go to overleaf.com. It will ask you to create an account. So use your university account if you would like to. And then it will show you a page like the one in front of you. On the left side of this page, where the mouse is moving now, you will write your code. On the right-hand side, it will show you the output, what it will look like as a PDF. Of course, I will show you how we download this PDF later, but again, we have to write our code here. So what I will do, I'll zoom in so you can see what I will start writing. So the first statement, in the first line, you should tell your LaTeX that which class you are using. Most classes, there are many different of them. The most famous one that we all use is we call it article class. Now, by this command, the one you see it here, I'm telling LaTeX, okay, we are telling LaTeX that the document will be of type article. So he knows how to format things. He knows how to make the output because he knows that this is article. class. So he formatted in a different way. So this is the first statement we write it in the preamble. Now, where I will start writing my document, I will put it between begin documents and end documents. So by this, everything I write here will be part of the outputs. So let me write something useful first. I will write hello, LaTeX. Now, this is what I will write. Let me show you if I click on recompile to the right, what would be the outputs. And you see, this is the outputs, which is only a way of writing hello, LaTeX. This will be the output that you will see. And this is what we expect. I just wrote hello, LaTeX. I'm getting hello, LaTeX back. But if you notice, usually the word LaTeX, let me zoom in here. The word LaTeX doesn't come like this. Usually it comes with kind of funny L, funny A, like the A is capital and then the tick is in the middle and then the E is small. And that you can achieve it by just writing this command. So I'll just write hello LaTeX. Now let's see what would be the difference if I just recombine my documents. Look at the right side and look how it looks in the right side. You can see it. It is hello LaTeX and the LaTeX is in this one. Now what happened here is a very important example of what we do. I tell the LaTeX a command and he gives me the output of this command. What I wrote here is a normal /LaTeX, but the LaTeX, the distribution, understand that I wanted to be this famous sign here, which is we call it hello LaTeX. So this is the first statement, first thing we would like to do. Next, I want to start with something more mathematically. So what I will do, I will put 2 forward slash. Let me zoom in here so you can see them. Now, those 2 slashes here, it will tell LaTeX to create a new line. So I will create a new line. I will go down. Now the LaTeX, when he reads those 2 slashes, he will know that the next thing he will write is in a different line. And here I will write the usual math equation. Let x be a vector in R3. That's what I would like to write. I want to write that x is a vector in R3. Now let's see what would be the output, and we will see what's the problem with the output that we see. Now, if you look at the output here, of course, we don't like this. There are so many things we don't like. First of all, this x looks like a normal x. It is not like a math x. So I need to make this as a math x. That's the first thing we need to do. And how we approach this and how we tell LaTeX this is a math, we put it between $2 signs. Now, if we look at the recombine, focus on the x, you see the x become much nicer, kind of italic. So this is the x that you always see in your textbook and everywhere else. Now, the second thing we don't really see in any textbook, in any exam, somebody write for me R3 like this. Usually the 3 should be in the top and the R should has a different thing. Now, how do I make the 3 in, as an exponent, as an power? We put this sign for LaTeX, which is kind of a triangle between R and 3. This means when LaTeX read the file, he will understand that this is indeed R to the power of 3, which usually we call it 3. And now, if you look at the output, yes, we achieved that thing by having R to the power of 3. However, we don't see this R in mathematics. This R has to come with something. So how do we make R looks like the R with 2 lines, that the one we write it in Blackboard? Usually we do the command math Blackboard, and then we put the R between parentheses. This will tell LaTeX please, if you see R, don't write it the normal R, don't write it the usual R, write it as the Blackboard R. However, if I just compile this one, I get an error. You see, nothing has been done. It's the same as before. And even he's complaining to me that there is an error. And if you can see, the error says it cannot read this math BP. Why? Because math BP is part of a library that I didn't tell the LaTeX to look for it. So I have to tell the LaTeX to use this library, which we call it package. So I'm saying the AMS symbol. Now, if I'm telling him, go to this library, you will find this command and you know how to deal with it. Now look at the distribution, how he will give me the output. And now that's the output that I'm looking for. You can see this is R3, which is written as really Blackboard math. So this is why we need the preamble to tell the LaTeX to look for specific libraries if we want to use something from that library. Now, finally, let me continue. So let X be a vector in R3. And of course, vector in R3, they have components. And let me write the component. And in this example, I will write the component as not ABC. I want to write them as alpha, beta, and gamma. Remember, sometimes we write the A as alpha and beta and gamma. Now, if I try to combine this one, I will not get what I'm looking for. Look what I get here. I'm just get what I wrote. I wrote alpha, beta, gamma, because I didn't tell LaTeX that those are a special thing, special alpha. How do we write the command for anything we would like to achieve? We write backward slash. So I do backward slash alpha, backward slash beta, and you can notice the change in the color. If you do the backslash, it become kind of purplish, and the usual one would be just green. Now, if I compile this, I should expect to get alpha, beta, and gamma. So just by typing in my keyboard /alpha, the output become the symbol alpha. And that's why LaTeX is very easy to use, because you can type it quickly. Don't care about the output will be fixed by the distribution. Now, just let me add something here. Imagine I would like this word, which is a vector. Imagine I want it to be in boldface. I want it to be bold. So you have to tell the command to the LaTeX to make it bold. So the command, for example, in this case, it will be boldface, text boldface. I put it between parentheses. And now, whatever between those parentheses, and now whatever between those parentheses, it will turn out to be the board. So if we go back here, sorry, just go back. Yeah, and you can see the word vector is different than the rest. It's bold now. So that's what we would like to do as first step here. Okay. What we are going to do next? Well, if you look at my output, it has no title, it has no sections, it has no chapters. I would like to organize myself, so I need to add sections to my document so that at least I know where I am and what I'm talking about. And how can we achieve this in LaTeX? I will go here to the top, for example, or wherever I want, and I will write section /section. And here I will write the section name, which is introduction. Now let's see this command, which called /introduction, what it gonna make in my document. So that's what we get in our document. We get a number, which is the section number, and we get the word introduction. That's really amazing. First of all, it gives numbers to the section. I don't need to write one introduction. The system by itself gives them numbers. Second, it makes them bold and looks nice. So this is the first section, which is introduction. Now, let me go to create another section, which for the next topic, I would like to talk about inline versus math display. Now, this will be another section. And imagine I would like to go ahead and do another section, which we call it important functions. This is another section. Now, if we compile, look what will happen. Sometimes the server goes down. Now look what happened. I have first section is introduction. Second section is inline versus math. And the third section is important functions. Now, let me add something extra. Imagine I want this important function to be in a new page. I don't want it to be here. I just want to push it to the next page. All what you need to do is you need to write for the LaTeX the command new page. This will tell LaTeX to start a new page with the next section. And you see now, there is no section 3 in this page, but if I go down and I go down and I go down to the next page, I will find important functions. Now, let me do something in the inline versus math. Why sections are very important? Because sections, especially if you're doing your 498, 499, sections are very important because this is how you present your reports. Your report consists of sections, chapters, subsections sometimes, and you need to organize them in a way that whoever reading them, he can see that this is a one section and a break line and another section, and so on. Now, let me go to do something in the inline versus math display. Now, imagine we have the equation, and I will write a math equation now. Now, let's see what this math equation that I will write. I will write an integral like this. Now, if LaTeX see the word integral, int, he will give you the sign of the integral. If he sees something goes down, like subscript, he will go and write the number down, which is, this case, I will use 0. And then I want it to go to infinity. So I will write /infinity. The LaTeX will understand to put for me the symbol of infinity. And then I would like to have a fraction. So what do? We write frac, and then we open two brackets. The first one will be for the numerator, which is in my case is 1. And the second one will be for the denominator. That's what we get. And I will write that this is equal to, of course, if we find this one, this will be tan inverse. And the answer will be pi over 2. So I will just write /pi. The LaTeX will understand this is just the usual pi. So this is my equation. If we try to read it, it's easy to read. Integral from 0 to infinity for the function that has the numerator 1, denominator 1 plus x squared, and the answer is fraction, which is pi in the numerator and 2 in the denominator. Let's see if we get what we are expecting to get. Exactly. You see how nice it is? A very easy, very simple equation. We could write it in less than 1 minute, and this is what we get here. So we get this as our equation. Of course, there are so many things we don't like. First of all, you see the equation is so small here, and the 0 is not exactly at the bottom, the infinity not exactly at the top. Pi over 2, you hardly can read it. If you notice, it's not something nice. And this is, we call it, this is inline math. Unfortunately, this is what we call it inline math, which means we write the math equation in the same line we write the other thing. Now, I will ask you, how about the following? Look, if I want to make the math equation in the center of the page alone, all what you need to do is you can use this notation here. Slash square bracket slash square bracket. And now you write the same equation. So I will do integral from 0 to infinity for the fraction that has a numerator 1 and denominator 1 plus x squared. And I want this to be equal, it's equal to pi over 2. And now let's compile it. It's the same statement, but look at the difference in the output. Can you see the difference? I think the difference now is so clear between the two lines. The display is exactly in the middle of the page, very large, very big, clear. However, the inline one is a little bit small. So always try to make your complicated formula as math display versus if you make them as inline between the lines. All right, so this is the math display. So here. This is math. And now I finish from section 2. I will go to the different section, which is the called important function. Now, what is important function? Is the following. To display some math functions. Like what math function? Like sine, cosine, len, tan inverse, inverse of tan. We use the following. For example, if I want sine x, I just write sine x and I put a slash between sine x. If you want tan inverse, of course you have to put it as a math, you just write tan to the power of -1 x. If you want the len, just len x, and so on. This is how we type those important math functions that we always use and we always in need to use. Let's see the output. Of course, the output will be in a different page. Let me just push this here. And this is the output. Sine x, tan inverse, len x, and so on. Looks very much nice. It is what we need them to be. Now, if we want to have some notations, like what? Some notations, like, for example, sigma sign or integral sign or the union sign. We need to write their codes. For example, what do we need to write? And let me now do it in line here. For example, if we write int, we get the symbol for the integral. Let's see. You see, we get the symbol of the integral here in the output. If I change int to, for example, sum, we should expect to see the sigma notation. That's the sigma notation. If we change it to union, which usually union, the command for union is cub, up, we get this notation. For example, you can write for me A/cap B, and you get this one, A union B. And that's how we do it in LaTeX. And this is our section of important functions. Next, we'll do something very nice here. Let me open a new section. So I will have another section. I will call it command section. Now, imagine with me in command section, I have two type of commands. So I need two subsections. So you will write sub, and then you write section, and you give it a name. So the first one, I will call it basic commands. And then I will have another subsection. I will call it parameter command. Parameters. Now, let's see how this will happen in my output. So this is my output now. You can see I have a new section called command, which is this one. And then I have two subsections. One of them is basic command, and the other one is parameter command. And he already numbered them according to the subsection, to the layers. So section 4 is command 4.1, basic command 4.2, parameter commands. This we call it subsections. Now, let me do what I need to do in the command section. Now, if you remember in Calculus 3, we frequently using the notation we really didn't like the word frequently. We usually using the notation, if you remember, I, J, and K. That's what we always do in Calculus 3. So if we try now to do them, I will just write, for example, 2i plus 5j minus 3k. Now, if I do the output, you can see the ijk here are not looking nice. They just usual I, usual k, usual j. And if you remember in Calculus 3, we used to have them as like a bold I with kind of a hat over them. Now, how can we achieve this one? So easy. How can we achieve this one? How can we achieve this one? We have to go to the I. And the first thing we do with the I is we make it math boldface. So I write math boldface. Now, let's see what would be the output. It will give me an I with a boldface, which looks nice so far, but I'm missing the hat. You remember there is a hat on top of I. So I need to write the command that, okay, make it that way, but also over it, put for me a hat over there. I'm sorry. Sorry, there's a mistake here. I think I forget to close one of the brackets. We didn't like overhead. Just let's stick with math boldface. Now the LaTeX is all over the places. You cannot read it anymore. Oh. Did I delete? Oh, I'm sorry. I deleted the document. By mistake, I deleted the document, so it was like I have deleted the whole file. So just let's stick with math boldface. Now imagine I would like to do the same thing for math boldface J and the same thing for math boldface K, and that is will give me IJK. Now, however, if I do this, that's a good practice to do it. But imagine if I'm doing a Calculus 3 homework. I have to do this all the time. All the time, I need to write I and J and K between those brackets, which kind of annoying, to be honest. So what I will do, I will define a command. I will call my command II. I will call my command JJ, and I will call my command KK. And I will tell LaTeX how, when he see II, what he need to do. Where I'm going to tell LaTeX, I'll go in the top. Before begin documents, I will tell my LaTeX here. So I will write new command /II, and what I want him to do with /II, which is math bold face, for example, I. And that's all what is needed here. Of course, I need to do the same for JJ. Copy paste. Okay. And this is a very, very good practice because it will save my time. Every time I need to display this I bold, I'll just have to use the command /II. And even if I would like to add something to it, it will be the same thing. So this is what we call it basic commands. Now, let me do a different command. Imagine I would like to do this one here. I would like to do x power 3 minus 3 power x. And imagine I would like to do this all over the time. Sometimes I want to use x, sometimes I want to use y, sometimes I want to use a 3, sometimes I want to use different number. So in this case, I need to define a command with a parameter. Let's see what this parameter will do. We go to the top as before, and we do command slash, for example, my new. It will take two inputs, so I put them between two square brackets. And then I tell LaTeX what I want you to do with the input. I will tell him that the first input, take it to the power of the second input minus the second input to the power of the first input. That's what my new command will do. Let's see how we will type it down here so that we display it in the screen. All what I will need to do is I call it my new, and now it will ask me for two inputs. The first one I would write X, the second one I write Y, and then when we display it, it shows exactly what we expect, x3 minus 3 power x. Now, if you want only to change the Y to, for example, W. So only I change the W, the whole command will change with me to W everywhere. You don't like the 3, we'll just change it to 9. Or for example, maybe C. So that helps you, especially when you use LaTeX, to reproduce your code. Just write command, and then if you use it over and over, it will make your life easier. Two more sections, and we will be good to go. Now, those two sections are very important, and this is, you will see it so much in your senior project, which is the section where you do theorems and proofs. Of course, in mathematics, we love theorems, we love proof, and that's exactly what we would like to do. So, how do I write theorem in a way that is really looks nice and the logic will take care of it? There is something we call it environment. So you start with begin, and then you write theorem, and then you end with theorem. Between begin theorem and end theorem, you need to write your theorem. So in this case, let x be an integer, then we have x times x plus 1 is an even integer, or any theorem of your choice. Now, if you write it between begin theorem and end theorem, the LaTeX will take care of the formatting. He will take care of giving this theorem a number if we need to, and he will take off everything that is needed. Now, in order for LaTeX to recognize theorem and end theorem, for example, if I compile it now, it doesn't show anything. It doesn't even read theorem and end theorem. So we need to go to the preamble and we need to add something for the LaTeX to understand. Usually this is a fixed thing here to do, theorem, and then I want it to display as theorem. This is just a command for the LaTeX to understand that please give me the notation for the theorem. And now you can see it here very clear that the LaTeX took care of the numbering as well as the way it's write the theorem. So theorem 1 given by this. Of course, we can improve this display, but I'm here going with the basic one. And that's how we write this basic theorem. Now, of course, we need to write a proof. So we'll do the same thing. I will come here and I will write proof as an environment and proof as an environment, which means everything I will write it here, the LaTeX will display it as a proof to the theorem. However, if we start by, for example, assume x is an integer, this is just the beginning. Now, if I try to display this one, again, I'm getting an error because I need to define what's proof to it doesn't even write for me the word proof. So I need to either I call a library or we define it up here. So what I will do, I'll just use package. There is a nice package, AMS theorem. Sorry, there's an error. I need just to. Just let me comment this one and see why this error keep coming with predicaments. I think the error because he couldn't read the package. Use. Okay. Nevertheless, we can just recall the name of this package, and I think this will avoid this error here. Now, let me go ahead and inside the proof, do the proof of this theorem. Now, if you remember, to prove this theorem, we will take cases. So in order to take cases, I will use an environment called itemize. Look what itemize will do. Item number 1, I will say let x be an odd integer. That's the first case for me. And the second case, I will take let x be an even integer. Now, let's see how this will be displayed. We can see them. It's already take care to make them as a bullet point. And in each case, I will do them separately here. So let's see how we will prove this theorem. I just want to show you the proof because I want to show you the environment align. Now, if x is an odd integer, then x equal 2k plus 1 or some integer. Now, I will start with a very important environment called align star and align, which will allow you to write multiple lines of math equation, and the LaTeX will display them in the middle of the page in a very nice way, very clear. Let's see how they will do it. So I'll start with finding the value for x times x plus 1, which will be equal to 2k plus 1 times 2k plus 1 plus 1. And then I will ask the LaTeX to go one step down, one line. And now I'll just write this is 2k plus 1 times 2k plus 2. And then to finish the proof, I will take the 2 as a common factor from the second. So I get k plus 1, which is an even number. Now, let's see what will happen if we do this. You can, no, it doesn't. It has a problem with align. AMS math package missing. So again, I have to call a package in order for my function to work. Now, if you look at the right side here, you can see that we reach to a line by line, but notice that the equal sign are not in the same alignments. They are not in the same. So what we will need to do, we need to add one code telling LaTeX, please take care that all equal sign, so you put just the ampersand, which is the and sign. If we add this one, all those should be on the same. And now if you look at it, it's a very beautiful way to express my thought of how to prove this theorem. Of course, if we do just a line without a line star, that will give them a number. To each line would give a number. Of course, depends on the question if we need to number them or not. Most of the cases, especially in those types of proof, you don't need to refer back to them, so you don't need to number them. However, I'll just keep them with number here. Now, if I continue with this theorem, let x be an integer. And I think now you understand that I will just repeat the same proof that x equal to k and so on, so forth. Just leaving at this point here. And that's the align environment and the itemize environment. Lastly, at any report, if you are doing 498 or 499, you need to write the table of contents. Now, everything looks good. Look at my document. It has section 3, section 4, section 5. Each section has a title. Now, imagine I would like a table of content. How you will achieve that? Wherever you want your content, I will put it at the last page. You can put it, of course, usually in the first page, and I will put it in a new page, by the way. All what you need to do is write this command, table of contents. This will tell LaTeX in the last page, write for me the table of contents, which will give you the section number and the title, as well as in which page this section appears. Of course, so far I just only did page 1 and 2, some of these sections in page 2, some of them section in page 1, and that's how it looks like as a table of content. Of course, this will be very important when you do later on your 498. And now imagine something else. Imagine, and this is we always do in math. Imagine this theorem, which is we call it theorem 1. I would like to use it somewhere in my reports. For example, just write a new section. I will call it label and references. Imagine this section, I would like to write by theorem number 1. We know that x plus 1 is an even integer. This is very good, but you see the problem of writing theorem 1 is not the way we should go around. Because maybe the theorem will have a different number. I'm not the one who will give the theorem a number. The LaTeX automatically give the theorem number. So what we will do is we will just write reference, and I will call it theorem THM1. Now, in order for LaTeX to understand that I'm using the number of that theorem, I go to the top of the theorem and I say label theorem 1. So this theorem, I'm labeling it with THM1. So whenever I need to call it, I will just write TH1. Let's see how this section will looks like. We go to the PDF. You see? It's automatically recognized this is theorem number 1, and I have it here. If I change the theorem, for example, I add another theorem before it, and it becomes theorem number 2. In this line, it will write by theorem 2. So I will never lose track of my theorem. And now, moreover, I can do the same thing for the section. I say by section, I give a reference for my section. I want section, which I call it section section function. Push this one. We know how to display functions. Now, I need to go and choose my section that I want to refer to. In this case, let me go to, yeah, here, which is label. Now, if we look at the output, it should give me the section Number 3, he recognized that this section, which I'm referring to it as sanction function, has number 3. And that's most of the survey I would like to do today for you, so that at least you get a flavor of how to use LaTeX, what is the capability of LaTeX, how the document looks like. Of course, we can enhance this document so much. We can add more things. For example, we can use package from the beginning. I think you can just make it full size. We can choose if we want it to be, for example, 12 points. You can see it here on the top left. I just write 12 points if I want it to be as 12 point, or if I want it to be very, very big, like example 25. Look now at the output, look at the right side, the lines will get bigger and bigger. So many controls, so many things we can do in LaTeX. Finally, if you just click here to download the PDF, you will receive the PDF file that you can do. Again, Overleaf is a very good compiler. You can use it. It has a very well documentation. All what you need is there. As a beginner, you should be there. However, as you can see from our presentation, that there are some packages that Overleaf has to be told to do. Of course, with the time, you will keep those packages fixed in any LaTeX document. So with the time, you will forget about them. But if you write a document from scratch, expect that you always will forget something and the compiler will have kind of an error. So by this, I'm done with my presentation, and I'm almost 2 minutes from ending the session. So it's a very nice and very good time. If you have any question, any concern, anything, I'll be happy to answer them. Just unmute yourself and let me know.
دكتور بالنسبة للرموز الثانية مثل إبسلون هي الإمبلايز كلهم نكتبهم بنفس طريقة الألفا والبيتا.
بعضهم بنفس طريقة الألفا والبيتا، بس إذا ما طلعوا مثلهم تقدرين ترجعي مثلا اوفرليف عنده جدول في كل الرموز وشنو الكود مالهم. بس المشهورين بيطلعون بالسلاش. Any other questions, concern, comments? Yes, Nasser.
السلام عليكم دكتور.
عليكم السلام.
إذا ممكن بس ترسل إلينا اللي كتبته في البرنامج حتى نقدر نطبق.
Hassan Mirza, I think you are raising your hand.
Hello, doctor. Could you hear me well?
Yeah.
Yeah, doctor. For inserting a picture, can I insert a picture in LaTeX? And moreover, and moreover, if I can, how can I adjust the spacing, horizontal spacing, vertical spacing, and let's assume I discover something new. Can I use my own notation, like tell LaTeX that I have my own notation?
Thank you, Hassan. Those are very important 2 questions. First of all, regarding a figure or a graph or a picture, you can do it easily and so easily, but again, you will need to use a package called geometry. That's the first thing. Sometimes geometry X also works. And then, I'm not sure if, can you see my screen? Just let me zoom in. And then somewhere in your code, you will write it include figure or include the graphic, one of the codes, and then you will write the file name, for example, my picture dot png, for example. Now the LaTeX will read this code and he will give you the picture. Of course, you can adjust the size by adding the parameter for the size. It has a whole library of inserting, including figures and graphics in LaTeX. Now, for adjusting the spaces. For example, this is a word, and imagine now you want a space, for example, 3 centimeter vertical space. Look, I just write 3 centimeter. I say this is another word. Now, if we run the program, we compile it. Of course, this will not work here. Don't have a picture, so it will not work. I will comment it by the so on. Now, if we look here in the output, you can see a whole space of 3 centimeter, exactly 3 centimeter. Same thing, you can adjust the horizontal spacing. But again, learning LaTeX, it takes time, it takes energy, it takes effort, but the results are really rewarding. Any other questions?
السلام عليكم دكتور عبد الله.
أهلا
بارك الله
بروفيسور.
فيك. بارك الله فيك على المحاضرة القيمة هذه، الله يجزيك الخير. حبيت أسألك بس هل في يعني رموز كثيرة يعني، فهل في دوكيومنت يعني نرجع إليه نتعلم منه؟
Professor Aish, yes, we have, especially in overleaf, in the same website that we do the compilation, there is a whole table that has all the symbols, all the notations.
بارك الله فيك، الله يرضى عليك، شكرا.
And that reminds me of the question of Hassan. He said, if I have my own symbol, for example, he has his own signature and he wants to have it a code, of course, you can do it in LaTeX, very easy. But usually, if you do it, it will be only for you. It will not work for anyone else unless you put it in a package, and that package has to be installed with other people.
شكرا دكتور، بارك الله فيك.
Okay. Any other questions?
Hi, yes, doctor, I have a question. Will this record be kept somewhere?
Yes, it will be kept in the same team that's here. And I will also download it, so whenever you need it, we'll share it with everybody. But it should be in this team, as long as.
Sure, thank you, doctor.
Thank you very much. And if you don't have any more questions, I think it will be a very good time to end up this session. We are 5 minutes over our time. So I'd like to thank you for your patience, and I really wish that you have learned something useful today. And please, if you have any feedback about this workshop, please share it with me.
Thank you, Doctor. We really appreciate the work done.